We have been asked to arrange the following standard forms in ascending order of magnitude. Looking at what we have over here, the first thing you need to consider when you are trying to arrange standard form in either ascending or descending order, consider the powers first. When the powers are the same as they are here, you don't have a problem. When the powers are the same, all what you need to do is to ignore the powers and check the decimal values. So ignore the powers and check the decimal values. Arrange the decimal values like in the previous lesson, after which you add the powers. So with this example, since the powers are the same, you need to ignore the powers. Looking at the decimal values, I have 9.5 here, 3.7, 5.6, and 1.2. The smallest of all the decimal values is 1.2. So the smallest becomes 1.2 times 10 raised to the power 3. Aside 1.2, the next one is 3.7. So I have 3.7 times 10 raised to the power 3, followed by 5.6, which is 5.6 times 10 raised to the power 3. The last one is 9.5 times 10 raised to the power 3. So that is it. When the powers are the same, it is very simple. Just ignore the powers and arrange the decimal values in ascending or descending. Our example 2 is also similar. The powers are in negatives, but all what matters is, are the powers the same? 10 raised to the power negative 6, the same here, the same here, the same, and the same. So what we need to do is the same thing. Let's ignore the powers and consider the decimal values themselves. So this is 1.1, 2.3, 2.34, 1.01, and then 4.02. With all these decimals, the smallest one here is 1, but there's another one here. So 1 and 1. Let's check the next, 1 and 0. Therefore, the 0 happens to be the smallest. So I'll be having 1.01 times 10 raised to the power negative 6 as the smallest one, followed by 1.1 times 10 raised to the power negative 6. From there, this is out, this is also out. 2.3, 2.34, there is 2, there is 2, there is 3, there is 3, but behind the 3 is 0, and there is 4 here. So the next becomes 2.3 times 10 raised to the power negative 6, followed by 2.34 times 10 raised to the power negative 6. Then the last one becomes the 4.02 times 10 raised to the power negative 6. The example 3 is quite different, because looking at the powers, they are not the same. Some are negatives, others are positives, and even with that, they are all different. So when you have anything like this, what you need to do is to change the standard form to the ordinary form. So let's change all standard form to ordinary form. 2.3 times 10 raised to the power negative 5 will be giving us 0.0 0, 0, 0, 0, 2, 3. That is for the first one. Then 9.8 times 10 raised to the power 2 gives us 980. Then 5.3 times 10 raised to the power 4 will give us 53,000. Then 4.2 times 10 raised to the power 3 should give us 4,200. Then 8.1 times 10 raised to the power negative 1 would give us 0.81. So now it is clear that we can easily compare. Therefore, the smallest value here is the 0.00023, which is 2.3 times 10 raised to the power negative 5, followed by the 0.81, which is 8.1 times 10 raised to the power negative 1, followed by 980, which is 9.8 times 10 raised to the power 2, and the next is 4,200, which is 4.2 times 10 raised to the power 3, and finally 53,000, which is 5.3 times 10 raised to the power 4. So this is how to convert the standard form into the ordinary form, after which you compare. But somebody can use the short way by looking at the values on the number line. Let's not forget that a bigger negative value on the number line is smaller than the smaller negative value. So on the number line, this is how it is arranged: negative 5 down to negative 1. Before 0, then there is 1, 2, 3, 4, in that same way. So somebody can choose to ignore this stage and use the number line pattern. This is the smallest to the left, followed by this. This is to the right, followed by this, before that.